Hello, my fellow students of CHM 515 Inorganic Chemistry. This is Alberto Villarengo, and I'm here presenting my final presentation on the properties of gold and ways to teach them to our fellow college students. Let me just share my screen. Share. All right, I hope you can hear me okay. I'm going to begin the presentation. Damn it, where's that? So there we go, slideshow. All right. Golden Learning by me, Alberto Villarengo, for class CHM 515. On today, our agenda and objectives, we're going to go over the importance of teaching the chemistry of gold. Go over methods of instruction for college students, particularly undergrads, and go over several examples of lessons for said students. We'll have a page on available resources for further education, and we'll finish it up with a summary. The importance of gold's chemistry. You see, gold has multiple beneficial applications that are critical to the modern human world. Medicine, energy production, and electronics. I mean, these are all things that we modern humans can't live without, and gold has many applications in all of them. It has peculiar chemical and physical properties. I mean, which can differ depending upon whether it's a solid hunk of metal or nanomaterials made into nanoparticles. Either way, these peculiar and chemical properties have made it valuable not just to nowadays, but also in ancient times too, like its malleability and ductility. It's also a very scarce resource, is another reason it's valuable. There's only so much gold in the world, in the Earth's crust, and we need more places to look, better ways to harvest gold so we can get more yield, and not to mention we need to find ways to extend its usage, like recycling or better alloys that can act equivalently as well as gold does or better. Not to mention ways to actually maybe find ways to detect gold at a distance. Teaching the topic of gold's properties in chemistry, it would help bring students to further understand its value and why it's important. Because you'd be surprised how many people think of gold as invaluable just because it looks shiny. That's not the only reason it's valuable. We need students to be inspired to use it for more than just flashy jewelry. Some methods for teaching undergraduate students. This will come in handy for teaching the properties of gold. Now, there are 3 learning theories for teaching young adults that I go with. There's the self-directed learning theory. This comes in handy when your students are more working on their own or online learning. You want to have the teacher must facilitate interest and collaboration. Students have to work with peers and colleagues to essentially self-teach while working on projects. There's transformative learning, where it's more reliant upon lectures, but the teacher's lectures are engaging in that they make students question what they currently know, opening them up to more possibilities, expanded consciousness, and more critical thinking. Basically, you can present a way to test students is to assign them a dilemma that they have to solve through various options, and the teacher grades them based upon their methodologies and the effectiveness of said methodologies. Then there's experiential learning. This is something we've all done. We learn by experience. We learn by doing. It's hands-on work. Teachers will provide students with new information, practice using the new information, and they challenge students to use that same information to solve a problem. These different theories can be applied to different focuses of teaching. There's a teacher-focused theory. It mostly ties into transformative learning. Teacher is an authority figure. We would deliver knowledge to students via direct instruction, like a sage on the stage. We test students individually, and this is best utilized within a lecture situation or demonstration. A student-focused learning, where the teacher serves as an authority figure and a director of participation. The teacher facilitates the students to engage themselves and self-teach. Assign the students projects to work on. You're like a guide, not telling them what to do, but you're guiding them towards figuring out what they need to do themselves, and you're supervising. It ties into the self-directed learning theory. Best to use when in a tutoring situation. Tech-focused. This one ties into experiential learning, as technology nowadays has provided us students with all sorts of ways to gain new experiences, virtual or real. Teachers serve as a supervisor. The new experiences are what deliver knowledge to the students. And the students self-teach by practicing in these experiences. These can be done through lab assignments and field trips, and the students report on these, what they've learned, and how they've applied these activities, and that's how the teacher can determine whether the students are learning or not. Here are some lesson plans examples on how these learning theories and teaching methods can be applied to teaching students different ways of gold. We'll go through gold as a medicine, gold in electronics, gold for energy production, and I say gold in art, but in actuality, I mean gold's physical properties, though that is usually used to make art, so we'll get to that in detail later. Using gold as a medicine. First, there's 5 steps. First, the teacher would introduce students to an anti-cancer medication, a known anti-cancer medication using platinum as its composition. In this scenario, the teacher would also explain its platinum-based composition, its method of action, and the current dilemma that this platinum medication, cisplatin, faces due to its side effects and its cancer becoming resistant against it. The teacher would go on to provide students with information on current research using gold-based drugs as alternatives to current anti-cancer drugs, followed by challenging the students to devise well-thought-out ideas on how to develop new gold-based cancer drugs. Get the students thinking, get some forward thinking going. Once the students present their well-thought-out ideas, teacher would assess and critique the students' ideas based upon the depth of their research, how will they address the dilemma, and potential applications of their work. Students would finally be tested with an examination of all the knowledge they retained. See how well they retained what they learned from the teacher and what they learned from themselves. Using gold in electronics, experiential learning. This is experiential learning by witness, not necessarily hands-on, but more by witness. A field trip. Students go to an electronics manufacturer to obtain information on how and why gold is used in the electronics industry. Gold is a good conductor of electricity. It's also non-corrosive, so it's good for an external wire coating, conductive wire coating. Students will then be presented a dilemma that they must solve using their newfound knowledge from the field trip. Like, pretty obviously basic, but here's an example. I got a wire that keeps corroding on me. Is there a new material, how to fix that? A new material for a wire? Gold. The students would would assemble their report for the assignment, which the teacher would would assess, looking for errors and noting them out so the students can study on those errors, tying into step 4, which is the student's self-practice, leading to students studying, trying so they can fix their errors on the upcoming exam in step 5. In example number 3, gold for energy. Using self-directed learning uses self-directed learning. The students are going to be teaching themselves more or less, but the teacher gets it going by providing an introduction on the ability of gold nanoparticles to absorb energy and facilitating enthusiasm and curiosity in the students, encouraging them, making them thirsty for knowledge, encouraging them to study themselves in step 2 and 3, while studying group projects, using the resources provided and maybe even their own external resources. Teacher will still be open. We'll leave students to their own devices, but it'll still be there as a guide so students can if they need help figuring out where to go, they can get it. Check it. This teacher checks on the students in interval progress, like after a month of the assignment, grades their thesis progress, and then 2 months later the students have a rough draft go and this teacher grades that, waiting till the final due date to grade the final project, in which the teacher grades based upon the thoroughness of the work and their group participation, as well as providing critiques on ways to do better. Here's the golden art learning. This is more about experiential learning through hands-on activities, and this is hypothetical, as you can imagine schools won't have students actually working with golden metal shop or laboratories. It's expensive, but this is a hypothetical example. Students will be educated first on the physical properties of gold. They'll demonstrate gold's malleability, ductility. The teacher will demonstrate gold's malleability, ductility, and other properties like density and reflectiveness, and provide lessons to students on how to use gold and the right equipment in metalworking projects. Going on to the metal lab, where the students will then be assigned to create an object during which they must demonstrate the properties of gold, malleability, ductility, and other things. They'll have supervised access to the equipment they need, and the teacher must be ready to guide students should they require assistance. Final assessment goes upon the student's work not by its beauty, but as an art project, but by its how well it demonstrated gold's physical properties. The teacher, if the student gets docked a few points, the teacher must explain to students why, what they missed, and what was done well. And the teacher finishes this lesson with a demonstration, with a final demonstration on the recycling or alloy making of gold to extend its usage. Further resources for finding information on gold. There are several, many online and in person. Online, you got for information on abundance, properties, and history of gold. You got chemlibretext.org, Britannica.com, thoughtco.com, and Astronomy Magazine. If you want to look into applications of gold, current research, IEEE Explore, Science Direct, and National Library of Medicine are all good resources for gold's technology, general scientific research, and medical applications. In summary, gold is a valuable resource, and it should be taught about more in school, particularly for its physical and chemical properties. If it were more affordable, chemistry students should get to work with it, engineering students should get to work with it, tinkering with circuits or metalworking or dipping in chemicals, all to better understand its importance as a resource. Unfortunately, gold is not that affordable. It's pretty rare because the planet's supply of gold is diminishing, and we need future generations to be able to extend it by recycling it or amplifying its properties with alloys. And then future generations will also need to know how to find more gold in an efficient and effective manner, especially should we look beyond our world into harvesting gold from asteroids, for example. Ultimately, this indicates the importance of being able to teach our best and our brightest, aka college students, all we can about gold. Thank you for your time. I'm Alberto Villarengo, student in Grand Canyon University in Chem 515. This here is my list of resources. I will attach this this presentation document to my submission, so feel free to look over the resources. Signing off.